Hello, good afternoon. My name is Deepyaman. Thank you very much for the introduction. Today I'm going to be talking about the composable Python native data stack. I mean, if that doesn't really kind of resonate with you, we'll go through kind of what each of these things mean. But in general, that was a great introduction in terms of that we're going to talk about like how you can, with Python, and not necessarily having to rely on maybe doing things in what you hear from like, oh, it's just a SQL-centric way, that you can actually build like a production-ready data stack. So I'm also very excited to kind of talk about this here. Like it was mentioned, I mean, I do work recently at Goldman Sachs on the core data platform. When I think of myself, though, I really like to think of myself as an open source Python developer. I mean, that's really where a lot of my passion and free time goes to. I used to be a data engineer myself. On a day-to-day basis, a lot of these things really come from my own experience as a practitioner and seeing what other community members were kind of running into and the challenges with using Python in the space. And so this is really a very personal thing to me. Okay, so why should you care? I mean, I gave the first iteration of this talk at SciPy earlier this year. Over there, a lot of the audience might be data scientists, people coming from like other science backgrounds. I imagine here, like people might come with kind of more mixed motivations. I'm sure there's a fair number of people who are data scientists themselves. There are also going to be people who are very much like data engineers or even other tool builders, probably more so at like a more science-focused conference. In that vein, like, I mean, I think I want to motivate both sets of audiences. So like kind of starting with people who are kind of more looking from a data science perspective. I mean, even if you don't really think of yourself as a data engineer, I think that's very often a very core component of what anybody is doing who's working with data. This comes from Monica Rogati's, I believe, 2017 article on the AI hierarchy of needs, data science hierarchy of needs. It's very likely you might have seen it before, but a lot of those activities that even as a data scientist you end up spending a lot of the time on are really kind of like these things which you might think of as data engineering tasks around how do we kind of clean up the data, transform it, deal with it kind of being in like these various like databases and so on. And it's just a very necessary part of any data science workflow. So maybe you're the one who's doing these things, maybe you work with some data engineers who are doing this, and then I think for a lot of this room, maybe you are also a data engineer who is doing this kind of as your primary responsibility. And then, it just may be that like you are already kind of working with Python. I mean, you're at a Python conference, and so you want to be able to kind of do these things well from a Python perspective. So we talked about the composable Python native data stack. In order to understand that, and for people who don't necessarily have this background, like what do we consider the modern data stack? So the modern data stack is this kind of SQL-centric idea that rose from DBT Labs. I believe it's been like about 10 years, I think 2016, that Tristan Handy, who is the CEO of and founder of DBT, Fishtown Analytics, and then now they're recently kind of become part of Fivetran, had come up with this, had coined this term of the modern data stack. The idea was that you had moved to this place where like a lot of your analytics had kind of moved to the cloud, and also that you had the tools that were able to kind of work with it, and the way that they worked with it was primarily through SQL. You can see like here a few of the tools that were kind of key to the growth of this. For example, like the rise of things like BigQuery, Looker, especially things like Redshift, and from the ingestion time period, Fivetran. And then by the time it was like 2015, 2016, this tool set had really matured to the point that this was basically the way that most people were doing data engineering. And this thing, really like one of the things that was core to this shift was the move from this idea of ETL, extract, transform, and load, to ELT. I mean, you'll have people who will call these things different things. You have also like ELTTT, whatever, to express the idea that you're doing like a lot of transformations downstream. But the core idea is that instead of you having to kind of with the advent of especially like these kind of cloud-oriented databases and kind of platforms, instead of you having to kind of think of it from the perspective of we're going to go to our data source and then we're going to, first we need to do a lot of work to figure out how are we going to model it correctly, think about how we transform it into the type that we need it before we put it into our database, which is not as much of a compute engine as, and very much more of a storage layer, that we are going to instead just say, hey, we have our data, and we're going to load it into our database, because our database or cloud data platform, whatever like we want to consider it, is not just a database and not just a storage layer, but it's also like a very powerful kind of transformation compute engine that we can leverage. So you had the shift from going from like taking your data sources and going directly to the and going through first like this whole set of transformations and then into the data warehouse where you would do this consumption downstream into just kind of the rise of these like ingestion tools that would just load the data into the data warehouse, and then you do your transformation for whatever you need, for whatever way you need to consume it. And this makes things a lot easier, especially for kind of a lot of these analytics, but even like data science use cases, because hey, you don't necessarily want to have to model all of your data up front and know exactly what you're going to do with the data, especially when you're doing more exploratory things. And it was one of the biggest changes in the paradigm. So this idea sounds good in theory, and it really took off. As of 2016, I mean, we mentioned some of these tools kind of being that popular set, and then you can see kind of the growth in terms of dbt. This is the data build tool, kind of its foundational SQL transformation framework that really became the standard, essentially. You have a number of other tools that then eventually came up in this space that were kind of competitors, often like still following the same dbt kind of like, how do we do SQL DAGs of transformations? Like one, how do we organize our SQL and then do it one after another in order to kind of do the transformations that we need to execute. But in general, like, yeah, this was the predominant way, and basically all data engineers kind of accepted this. And it really works great, right? I'm not here to say that this doesn't work. But the thing is that, again, like kind of coming back to the fact that we are at a Python conference and we are excited about using Python. Maybe we do want to be able to use Python. So yeah, what about that? Like Python has exploded in terms of its popularity over the past years, especially driven by initially data science, ML kind of work, and now especially with AI. This is as of last year. I'm sure that Python share is even higher. This is also not exactly my favorite visualization. It was just something easily accessible. If you look at the Stack Overflow developer survey, it's a little bit nicer and that actually still shows SQL as well. But you see that like these are kind of like similar in terms of being extremely popular languages. What's first, what's second, doesn't really matter. Yeah, Python has become extremely popular, but it's never been considered this like first-class citizen of the modern data stack. A lot of tools have added Python support. So for example, you think about something like dbt. If anybody has used it or is familiar with it, dbt does have Python models. And models are essentially not machine learning models, but what they call like these SQL files or like other ways of representing your SQL transformations. And dbt has support for Python models, but it's really like kind of more of the second-class citizens, and it's kind of meant for those cases where I wasn't able to do it SQL. Let me find a way to do that with Python, but it's not that well supported. It definitely has limitations in how it's kind of done. So like you don't really have this kind of like Python first approach for a lot of these things. So what can we talk about here? So one of the core things that we need is that all of this is really based around the use of SQL. And in order to be able to then fill this gap, really look at it from that Python first perspective, we need to have a solution here. And I mean, it's not that Python cannot scale in the way of SQL, right? Like we should note that Python has been used at scale for a long time. Spark has been a thing. I mean, like PySpark has been a thing. And Databricks has been quite successful off of this platform. Dask has also been a thing. I think they've often been also at PyData. I haven't seen them this time, but it's very possible to kind of write scalable Python code in Python. But I mean, this is very much like kind of an engine, like compute engine specific thing. Maybe you have something for Spark. Maybe you have something for like something built kind of more from the Python native space. And Dask, you have also like a lot of other libraries like Snowpark and things kind of more recently kind of catching up to that demand from a Python perspective. But that still leaves kind of all of these other interfaces, and also like making sure they're catering to the way that data scientists, data engineers, people who are really Python oriented want to work. And for a lot of these people, this is like dataframe libraries. One of the things which a lot of people, when they think about data engineering in Python, they think about, hey, I'm going to go and use polars, which is great. It's very efficient for kind of local work. Or I'm going to use pandas. I'm familiar with that. But the thing is, all of these things really take your data from the database, they bring it into memory, and then you're kind of working with it locally. If you put your data engineer's hat on, and if you're like, let's say you go to Reddit, look at the data engineering subreddit, and you see comments like, if anybody ever brings up Python, I mean, the main thing will be because they're thinking about it from this perspective, and that's just not the way that data engineers like actually work at production scale. Data engineers work by leveraging the fact that all of these kind of like cloud data warehouses, compute engines, and such are like these effective transformation tools. So like if your data lives in BigQuery, you want to do the transformation in BigQuery as much as you can. If you're using Trino, you want to use Trino there. If your data is in Databricks, you want to use Databricks, MS SQL, MySQL, whatever it is, right? You want to be able to leverage that. And this is where there's an open source library called Ibis, which provides a data frame library that allows you to kind of interface with any like database or other backend that you're looking to do. So it supports 20 plus different backends, and this is going to be like a foundational piece for how we think about working with data using Python and data frame APIs in a natural way, but having the power of SQL under the hood. It's a deferred data frame API, so if you're familiar with lazy frames, it's very similar to that, and in the sense that your compute doesn't happen until it needs to, but instead of it happening kind of then on your local machine through kind of like, in that case, polars, what happens is for most of these engines, for basically everything other than Polar's engine under the hood that Ibis supports, it gets compiled to SQL, which gets executed. So essentially, you have SQL equivalent code in Python. One of my favorite talks on this topic actually was at last year's PyData New York. Gil Forsyth, one of the Ibis maintainers, gave a talk on not letting the engine dictate the interface, where the interface is either, like, you can think of SQL as an interface to working with your data, or Python is working as an interface with data. I would really suggest like, taking a look at that talk on YouTube whenever you get a chance. It's a really wonderful talk. So one of the other like kind of final things I want to talk about is that Ibis enables language interoperability. So Ibis under the hood, it represents and constructs this sort of like IR, intermediate representation, that it then compiles to kind of whatever dialect of SQL you're looking to execute on. And one of the like super powerful things of this, and like one of the ways that people who end up using this through like some of these other aspects of the stack and things like that, is that it allows you to kind of move from engines for your local work to your production work. So for example, one of the people that I know has been kind of using this for a while, they like to use polars locally because, hey, that's a great local interface. A lot of people also really love DuckDB. That's the default backend for Ibis, actually. But then in production, their company uses Databricks, or other people, maybe it uses BigQuery, maybe it uses some other Ibis-supported engine. And by using something like Ibis, you're able to kind of have the same logic execute locally and in production at the right, using kind of like the right engine for that scale. There are minor differences sometimes, but Ibis does a very good job of abstracting over this. Some stuff like regexes, yeah, you might have to be kind of careful about. But overall, Ibis is kind of very well tested across this sort of space. One of the other things, actually, the way that I first got into working with Ibis was I was working at a company that, at a small startup that was working on real-time machine learning feature platform. And one of the challenges there is that, hey, I need to be able to compute my features in real time, streaming features, because that's like the purpose. I want to be able to kind of have very fresh, low latency features available for my ML models. But at the same time, I'm not going to be training my ML models on streaming data like continuously. I need to also have like all this kind of historical data. So I'm going to be having that available, like kind of a batch historical data stored in Iceberg. And so the way that we actually were using Ibis at that time and how I kind of got into it was the use of Ibis as this abstraction between batch and streaming. So one of the things that first worked on was adding a Flink backend for Ibis. So that's just another cool aspect of being able to leverage Ibis. Okay. So coming back to data engineering, the engineering lifecycle composed of like many different stages. We can kind of distill it down to maybe like 5 main pieces. And so this visualization, it comes from the Fundamentals of Data Engineering, written by Joe Rice and Matthew Housley. You'll notice that these components very closely mirror those that we saw like a few slides back. But we're going to really focus on kind of breaking it down this way and kind of go through it one by one. Because if we're going to have a like Python data engineering stack, then we need to kind of make sure that it's something that covers all of these different pieces. So first up is data storage. This is kind of like more of a cross-cutting concern, and it's also not something that we're going to spend a ton of time on because it's something that Ibis largely handles, and like the engines largely handle natively. Your data storage, it can come in many formats. It can be like a data warehouse. I mean, especially with kind of work on the lakehouses side. I mean, you have people who are using a lot of Iceberg, Delta, things like that. You also have your databases themselves, like Snowflake itself is also a storage engine. You could use that as a storage engine. It could also connect to external compute. There's a lot of different options here. And Ibis essentially supports them all to some extent. Some of these things are evolving at different, in a little bit different ways. Like for example, for Iceberg, I think the support is a little bit more engine dependent, just because a lot of engines still don't have very native support for Iceberg. Ibis tries to kind of be a little bit opinionated around the fact that if that engine does not support Iceberg, it does not just try to kind of like shove in some hacky support for Iceberg, especially kind of like using some libraries which will under the hood maybe not be as performant. It's kind of waiting on some of these things. But generally, yeah, for the most part, if you're using kind of like a major engine, supports as well, and especially if you're not necessarily tied to some of these kind of newer formats, Ibis does very well. And this is something that'll continue to evolve as things get better supported. So let's move on to data ingestion. So this is that extract and load. How do you kind of get your data from wherever it lives and move that into wherever you're going to actually be working with it. So I'm also not going to spend a ton of time on ingestion, and this is not because like it's not an important piece, but it's actually because like this is something which I feel like I don't really need to convince people that a good Python alternative exists. So DLT or data load tool is kind of like a great option for using for this like extract and load data ingestion process. It's already pretty widely used. It's come up as a very significant competitor to some of your established tools like Fivetran, Airbyte, and so on that people might have been using otherwise. And it's Python native, and one of the things which I really love is that it's really built on the fundamentals from the start. So like it's like you've probably heard a lot over the years, especially in the past few years, about Apache Arrow. It really leverages some of these things to kind of make sure they're efficiently moving data by reducing copies as much as possible. And it's a project that is really done well. It also supports things like reverse ETL. That was something that like kind of glossed over a little bit earlier as like a subcategory of ingestion or data movement. And it supports a number of these popular destination sources out of the box. And it even comes with like a built-in Ibis integration. We can just jump into a quick demo. So let me see. So I'm going to go ahead and let's see. We can look at this file system pipeline. Now this is a very simple example of what DLT pipeline can look like. Obviously, our data doesn't necessarily live on disk, but I want something I can run very easily here and not rely on anything. So if you've seen like the Jaffle shop, which is like the canonical DBT's example of, oh, what do we use for the modern data stack? It's essentially a shop that's selling Jaffles, which are like these sandwiches, and it has some like information on like kind of orders, customers, transactions, and so on. We're going to ingest some of this data, and you can see that we have it on our file system. This is what the basic syntax kind of looks like, and it's just a Python script. It's not like kind of managed tool or anything. And if I do Python run that, we'll see that, okay, it has loaded stuff into our destination was DuckDB. It's loaded into the jaffleshop.duckdb database. So great. We'll just believe it's there for now. We'll actually get around to exploring the data a little bit later. In the meantime, let me go back to this. Yeah, this was the example. We just kind of went through it live. So the next piece, which I want to talk about, is data transformation. So this is kind of where it all began, at least for me. As a data engineer, so I was using kind of Kedro a lot for that data transformation aspect, because a lot of the work we were doing was with PySpark, especially clients when I was kind of working with Kedro as a practitioner myself. Kedro is a data transformation framework. So if you've, like, I think even, for example, if you saw Dawn's talk earlier, like one of the things that keynote yesterday, one of the things she was talking about was about like how you can kind of think more about like productionizing some of your notebooks, how you can kind of potentially move your code into Python functions, and how do you kind of string them together into pipelines, how you can have some of this stuff abstract as configuration, so you can abstract between different environments or around how you're loading data and things like that. Kedro is a framework that helps address some of these ideas of like kind of modular, reproducible data science and data analytics and data engineering that originated back in, I'd say, around 2016, 2017. I got involved with it in 2018, and it was open sourced in 2019. And is right now, it's part of the Linux Foundation AI and Data umbrella as a graduate stage project with fairly wide, diverse technical steering committee. So that's basically kind of what Kedro provides. It provides out-of-the-box solution to kind of structuring your data pipelines. And that is very analogous to what DBT, the core of your like kind of SQL original modern data stack is. Actually, one of the people that I used to work with, Cody, he's right now a product manager at Ascend.io. But he used to be previously on the DBT team. Actually did some of the work on introducing Python models, I believe, there. But like when he first learned about it, like, yeah, it was just kind of immediately clear like how it's very analogous. It's just instead of being like a data analyst, and that's where kind of like DBT rose from, if you were like a data scientist, you need that to solve that same sort of problem around like, how do I structure not just my SQL code, but now instead of my Python scripts in a way that they're kind of reproducible, I can just run them as a pipeline through a command, choose what I'm going to run, and so on. Like Kedro solves very much that same problem. So yeah, nodes are basically just Python functions, and it has also like this idea of data sets. Data sets are basically an abstraction for how you load and save data. It's extensible. That means, and we'll see an example of this actually later, that you can, it is kind of a built-in hook system where you can kind of integrate with a lot of other tools at various points in the life cycle of a pipeline run. Finally, we talked a little bit about how it is kind of something that has matured over time and is very widely used. So because Kedro is essentially just running Python functions for you, that also makes it easy for us to work with a dataframe library, something like Ibis. So if I kind of move forward here, one of the things which I kind of wanted to also highlight as we are here talking about kind of the use of Python, we said that, yeah, SQL has done very good, and it's a great language for data engineering. At the same time, like if you have done a lot of work in SQL, like there are places where SQL doesn't necessarily look as clean. One of the things is if you've kind of seen like, oh, I need to create like a loop over things. That's when SQL actually gets polluted with Jinja, and you're essentially using a templating language in order to generate SQL. Like if you think about it, if you can do this in Python itself, hey, that's just like a for loop. It looks like, I mean, Jinja is also Python inside of this templating language, but applied to SQL. And you can just have it all kind of being in Python. Another thing, which is like if you have ever worked with like recursive CTEs in SQL, like these can get very hairy very quickly. Python, especially using something like Ibis, a nice data frame library, it allows you to express sometimes these kinds of more complex logic more easily. At the same time, one of the benefits of using Ibis for this is that you can always drop into the underlying backend or SQL if necessary. So again, like before we move on to that, we can take a look at a quick example here. So I've created a Kedro project here under our source Jaffle shop, and we can take a look at one of our pipelines. So let's look at pipelines. We have a data processing pipeline, and we can look at the node for this. So as we kind of mentioned, nodes are essentially just Python functions. Here we have something which takes our customers table, our orders table, our payments table. These are all represented as Ibis tables. It does whatever, like kind of combining them, doing the aggregations, and create some final thing. I've actually like essentially left the same sort of variable names as are in the original SQL. If you were to pull that up side by side, you could even compare it. And we can see that this then gets called in our pipeline. So our pipeline definition here is just going to be a definition of like what each of these nodes does. So we have our function, in this case, process customers, and we reference some inputs. So our staging customers, file staging orders, staging payments, and so on. I can see if I can also just show what our whole pipeline looks like here. Let's see. Yeah, so this is kind of like a visualization. It's a very simple pipeline for the Jaffle shop. It's very much a demo project, but we can see what our whole kind of transformation pipeline looks like. And if I come back here, let me kill that, I can run my pipeline. This is going to take the ingested data. Again, very fast pipeline. We can see that run these 5 nodes that were defined there, and we have our data populated. Okay, so the next piece that we're going to get to is the data validation piece. Oops. All right. So data validation, for anybody who's kind of worked with like data or done some data engineering, or I mean, even if you're not a data engineer, you know that data quality is very important. Garbage in, garbage out. So one of the tools that has really kind of risen in popularity, actually, the reason I personally got to know about it was I was kind of working a lot with and looking a lot into things like Great Expectations, another data validation framework before. I just happened to see a lot of Kedro users saying like, hey, we want to be able to use Pandera with it. Do you have a guide for this or something like that? Pandera is another like framework for doing data validation. If you are familiar with some of these frameworks, or Great Expectations, I would think it's like a very data quality oriented, like you really care about this sort of framework. Whereas Pandera is more of a lightweight, like, hey, I want to execute some data quality rules and do some checks and things on top of the data, but it's just more like a utility library. One of the reasons like a lot of people end up liking it is because it is more lightweight. You don't have to basically say like, I have yet another framework that I'm adding. It's more like a tool. It supports a lot of different backends. So it originally started with support for validating pandas data frames. It terms itself as a data frame validation library. It then eventually had things like Modin, which is like, oh, I can run pandas code on various places. PySpark, and now it also supports, well, polars, and now it supports Ibis. This was actually something which I started doing in my free time a couple of Christmases ago. And earlier this year, kind of the first version was released, and it started to kind of get used. So it provides common, like built-in checks for common validation tasks. You can also define your own checks for whenever you have custom rules, and it will execute using whatever backend you have. It also has some of these integrations with like other tools across the Python ecosystem. Because it's gained a fair bit in popularity, you see a lot of tools kind of supporting defining like schemas in Pandera and so on. So this was, as of version 0.25, this was released, and there's been some improvements since, and it's kind of one of the things which we can also take a look at here. Most of the standard functionality is supported on the Ibis backend as well. So if we go ahead and take a look at an example of this, we can replicate again, we're just going to use one of the examples of something from the like the DBT test examples, and we're going to try to replicate it. I can actually go over to an actual demo of this. So if I look at this, we have an example of a check. You can define it in like multiple ways. This is kind of defining explicitly as a data frame schema. You can also do like a class decorated way of doing it. You can check the documentation on this, and I'll drop some links to it at the end. That'll kind of walk you through a lot more of the functionality. But here we've essentially defining a few things. One, we're defining like what does our schema look like for our tables, like what do we expect? We expect like to have an order ID, amount, status columns, and we specify what we expect that type to be. And we can also define some checks. This is using like a built-in check. So the is-in check is something that's built in. You can just use out of the box. So like, okay, this check is, I want to check that my status is going to be one of these values. But then we can also build our own checks. So for example, if we want to do a check that the total amount is positive, we've just defined a Python function in a way here, and then we can use that as our check function. And we can execute this. So if we execute this on our existing data that we've ingested, turns out the data is actually fine, nothing happens. Because there's no problem. So if I go ahead and do this instead, and we can see here that I've introduced a -50 for the amount representing a return. But actually, like the returns are represented differently in the actual data set. So we are just introducing an error. And now if I do this, I can see that like, I got a schema error. It's able to kind of validate this and run it. So this is like, OK, so I guess this is going to be how we can address the data validation on whatever kind of backend we want to support. All right. Last but not least, BI analytics. I would say especially on the kind of charting, dashboarding side, this is the area which I personally have the least experience with. But at the same time, I know this is a super important part of the data engineering workflow. I myself had primarily kind of worked on more for the like data engineering for AI ML use cases downstream, and not as much for dashboarding, except for a long time ago when I was using stuff like ClickView and Cognos. But that was before I used Python. But in terms of this, if we look at the dashboarding side of things, Ibis supports a variety of data visualization platforms, data visualization packages and tools. One of the things which is quite nice is, like, for example, Streamlit, very popular library. It defines a connection interface for how do you kind of connect to like external data sources, so it could be for database and things like that. Ibis actually has built-in support for the Streamlit connection interface, so it allows you to kind of easily work with kind of whichever Ibis backend you're using and wherever your data lives. You can use Ibis and integrate through that connection interface in order to do that. It also supports a variety of other data visualization libraries. All these are kind of documented on the website for Ibis. In addition to that, like one of the other things which is cool, like I fairly recently started using PyShiny, like the Posit people are here. You can talk to them. It works with that. Like actually at SciPy, they helped me kind of work through like, oh, I was trying to get something dashboard using Ibis, and hey, it works, nice. So one of the things is that like for a lot of these things, you might need to just, eventually your data comes out of the database and into whatever tool, into whatever the tool supports, which might be pandas or polars, data frames, or maybe something else. It might not all be lazy for these aspects, but a lot of times by the time you're doing visualization anyway, you've kind of aggregated to some point where your data is not as large, but you do want to be able to, like, for example, in Streamlit, you want to be able to define your functions so you're able to access that larger slice of data, be able to do that efficiently, get it into that piece which you're able to visualize, and then show that. The new piece on this, which I'm really excited to kind of talk about, is the boring semantic layer. So I don't know how many people know what a semantic layer is or have worked with semantic layers. So if you haven't, like, I will admit that, like, trying to explain the semantic layer is a little bit challenging, even the whole presentation, but I'm going to kind of really quickly try to say, like, a semantic layer provides a way of standardizing how you've defined your data models and your dimensions and measures and things for, like, how people can work with your data. You can think of dimensions as things you can group by in your data models, and your measures as things that you can compute as different aggregations. And this provides a common language, like, across an organization for how you're doing this. So in order to do this, there's a new tool called the Boring Semantic Layer. It implements a Python first. It's not really tied to kind of any sort of commercial product, which a lot of semantic layer implementations are. If I go in here, and then I'm going to use, like, so Kedro has this concept of a data catalog. So when I do this, I can see what's in my catalog. I can look at, for example, one of the data sets in my catalog. This is kind of what I was talking about, that level of abstraction. If I look at orders, this is, like, one of our data sets. But what I can also do here is I can do like a group by, and in this case, I have defined status and order in total as, like, a dimension and measure that I can group by and execute across. So I can see, like, oh, this is a breakdown of it. And one of the other things I can do is I can even chart using this and kind of just get a chart out of the box based on my semantic model. One of the things I don't have set up, and through this integration, which is essentially Kedro plugin, which is still very much in progress, is the AI integration. So one of the other things which is cool, you can read about it online. With the Boring Semantic Layer, it also supports an MCP server where you could be like, hey, I want to, like, look at this over the last quarter, and based on this information that you've defined. So if I cancel this, and if I look at my configuration in my catalog, through this integration, I can see that I have defined this sort of metadata around, like, what do these different fields mean, and so on. And so, like, your AI model is able to kind of have some additional context, or your human, around, like, what to do with these things. And then with the MCP integration, you can actually do a lot of things through, like, Claude Desktop or something like that. So with that, I think I'm running short on time. So I'm going to wrap up by kind of moving to... Okay, we saw an example. So what's the state of this? I actually didn't change this intentionally from my last presentation back in the summer. So yeah, I mean, it is still relatively new, a lot of these things. A lot of them are evolving, even though some of these libraries like Ibis, Kedro, Pandera have been quite mature. Upserts and Ibis was something that was not there. Very recently, actually, I had the pull request accepted for upsert support in Ibis, so that's exciting. That's obviously a major piece of a data engineer's workflow is needing upsert support. The Kedro data set still needs to be updated to support that, but that should be a fairly easy thing whenever I kind of get some time. The community integrations, some of these things like the Pandera integration it exists, but it's not super mature and needs to kind of be, like, worked on. One of the exciting new developments since that time is that Kedro has added, like, is adding native support for pedantic parameters. So that's for basically, like, how do I validate and my like parameters using the pedantic framework. By following that same model, one of the things that we're thinking is that we will be able to also support validating Pandera schemas. And then the last thing is, of course, like I just showed this boring semantic layer integration. That itself is a very new project, very exciting project. But at the same time, like it's very recently, I've updated this to kind of support the V2 of that, and we'll see new things. One of the other things which would be, I'm excited to see, like there are people who are using various pieces of this in production, in production in various stages. One of the things which was cool to see was even when I joined my new company, I'd seen like, oh hey, people are like a month before I joined, they'd done an evaluation and they'd landed up on using Kedro and Pandera, and they'd looked at using Ibis and things. So it's exciting to see more of this happening. There's not so many like real-world open source examples at scale. If you end up doing anything cool, definitely share that with me. And of course, there's the awareness piece. I think a lot of people still, when they think about data engineering with Python, they are thinking about pandas, polars, and things. And more people are understanding and seeing things like Ibis and other things in the space. And I mean, that I think is a great move towards that. If you want more information on this, here are a number of links. You can also find, I'm happy to also share the link for this presentation, and I think I am definitely out of time.